Yeah, we can start now. That means what I will do today, I will talk about section 11.8, the power series, and hopefully I can also talk a little bit about 11.9, the power series representation. And that we will see what it is. Okay, that means let's start. What we have. We're still in chapter 11, of course, we can see this, and we will still talk about the infinite series. But now we will look at them from a little bit different perspective, and we will call them power series. So let's see what we have. The power series, it's still a series in which each term is a power function. Okay, that we can kind of see the power function. The power function is like a polynomial with, in this case, infinitely many terms, because power function contains like the x to the power of a number, x to the power of 1, x to the power of 2, 3, 4, and so on. That means the general formula, it's the coefficient c sub n, because each term should have a coefficient. Okay? And then we do have a power form, x to the power of n. And n still stays as a positive integer. Like as I said, 1, 2, 3, 4, and so on. Or we can even add the 0 if we like, x to the power of 0, which of course is the constant term. Okay, that means x will be the variable that we can see. We have something that we don't really know. It's like it's a variable. It's not a given number. It's just x. And c sub n will be the given value, the constant, the coefficient. Like sometimes it will depend on n. That's when we may have, for example, the formula, I don't know, let's say 1 over n. And that means this will be 1 over 1, this will be 1/2, this will be 1/3. No, let's keep, no. Let's say n, that's correct, because n is 0. That means this will be 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. Okay? That means we may have a formula for the coefficient. Sometimes we'll have just the constant, like given value 5. That means each coefficient will be 5. Okay, that we can see one more time, coefficients and the variable. Okay, that means that's how we can create a power form, power function, and we can see infinitely many terms because n goes to the infinity, which means the degree of this power function is also like huge, right? I don't want to say infinity. Okay. And we will still talk about some convergence of the power series. Okay, that means now the power series may converge for some values of x, of course, and may diverge for some values of x. That means since now we do have that x, that unknown, the variable, we may have a situation that the power series will be convergent and divergent for the certain values of x. Okay? And we have to figure out this value, I mean the set of these values. Okay? So now the sum of the series is a function, is a power function, and looks like that. We can see power function, but we can only name this as a function if we will talk about the set of x that this series is convergent. Okay, that's one more thing. We can say one more time that we do have a power series, c sub n, x to the power of n. And that's definitely the power series. But now, what terminology we adding? We're adding something that we can call this as a function, but only if we think that the domain is the set of the values that is giving me convergence. Everything, all of the values of x that will give divergence, we're not including, we're not talking about this, and this will be not the part of my function. Okay, that's how we can call power series a power function. Of course, with infinitely many terms. Only with the domain of this function, which means the function is only defined on the interval where power series is convergent. Okay. And now let's start investigating some, we will call interval of convergence, because the interval of convergence will be the set of X that is giving a convergence, and of course will be the domain if we want to call power series a function. Okay, so I have a first example, and what I did, I actually said that the coefficient C sub n is 1. It's simply 1 for all of the terms. 1 x to the power of 0, 1 x to the power of 1, 1 x to the power of 2, and so on. Okay, and now we can easily see, okay, that this power series actually becomes a geometric series. We can see x to the power of n. N is placed in the exponent, right? Only in the exponent, we remember this. And we do have 1, x squared, x to the power of 3, 4, 5, 6, and so on. And if I will check the common ratio is always the term a sub 2 over a sub 1, which, for example, x over 1. Or I can take any neighbors, any preceding terms, a sub 3 over a sub 2, but I will always get x. That means the common ratio is x. And based on the previous concept, previous knowledge, we know that the geometric series, it's convergent only if the common ratio is between -1 and 1. That's it. Okay? That means the common ratio is only between -1 and 1. Oh, okay, that means that's the first thing. I have my power series. I can call this power function, but only if the domain, the set of X that is giving convergence is from -1 to 1. And as I said, we will call domain is more like, it's for function, of course, but we will call this an interval of convergence. Yeah, you probably know this, but interval of convergence, that means the interval of convergence is only the set of X between -1 and 1. And then I can talk about this as a function. And that we do have an interval of convergence. I will take the advantage of the space. That means this is X, and we can see an interval of convergence is between -1 and 1. And also what we have, because we have to focus on few things, and I would say 3 different things. We have an interval of convergence. And usually it will be the interval like from the finite number to the finite number. Okay? Sometimes we will check the endpoints, but not in this case, because we know that we can't accept 1 and -1 for the common ratio. Okay, but looking at this interval, we can definitely identify a center. Okay? And of course, from -1 to 1, the center is 0. Really nice. Okay? Also, that means we will call that center, we will call A. Okay? The center of the interval is 0. Also, we would like to see what is the distance from the center to the edge, both ways. And the distance from 0 to 1, of course, is 1. From 0 to -1 is 1. And we will call kind of like a radius. The radius is 1. Okay, that's the main concept for this section. We have to identify an interval of convergence, the center, and the radius. And of course, having an interval, how easy and how simple it is to identify the center and then the distance. Okay? The distance from the center. Either way, because it must be the same. Okay, interval, center, and the radius. But let's see. Because I think I'm trying to squeeze the entire section on one slide. Okay, that's me now. Since we know what is A, okay, A is the center, we will have a little bit more general formula for the power series. And we have a summation from 0 to infinity, still C sub n, That's the coefficient. But now my power form x to the power of n becomes x minus a to the power of n. And having this, we will see right away what is the center. Okay, that we can see the quantity A actually is the center of an interval of convergence, because everything is centered around A. And we may call this power series in x minus A, which we know what A is, or we may use this description, a power series centered at A, that's perfect actually, or about the A. Okay? We know what A means. That we can see how helpful it is, even without starting any calculation for the interval, we will see the center right away. And we will follow some steps, we will follow some protocol to get the solution, to get an interval of convergence. And even if we make some mistakes, we will, because we can check ourselves, we can always look at that center. And if you will get an interval and the center is somewhere else, then you can think, oh, no, something is wrong. Yeah, that means how helpful it is to have that form and know the center. Okay, and I can come back for a second, and we may see here, it's only x to the power of n, which means what quantity I did subtract from x to have just x to the power of n. Thank you, Ryan. Of course, 0. That means if it's only x to the power of n, it's obvious that the interval of convergence will have a center 0. Yeah, that means this is that 0. That's my A, if I like to keep my notation. Yeah, it's nice. And that's definitely because that's actually, we will not go really deep to prove this. This is just how the power series is created, constructed. Always that form and that number will be the center. It's like, it's proven. Okay, let's go a few steps further. Okay, a few notes, because we might be a little bit confused with that power of 0. But now we will just adopt the convention that x minus a, even if x is a, you can see this, even if x is a, with this will give me a minus a is 0. But please remember, we will not think that this is indeterminate form. No, for the power series, we will just simply say this is 1. Okay, that's mean I know maybe this looks weird without any proof, but that's how it is. Of course, again, it is proven, always is 1. Because the only thing is that I can maybe say as a evidence, this is like exactly A, and this is of course exactly A. That means this is exactly 0. It is not like a function that is approaching 0, and we don't know what's the speed, what's the pace to get that 0. It's like, it's a number, it's just 0. Okay, that's the reason that we will say that is 1. Also, for the interval of convergence, that's quite helpful message. When x is A, actually, all terms are 0. Yeah, perfect, 0. So the power series is in the formula above, it's always convergent, always converges when x is A, which means when x has the value of the center, because I would like to name this as a center. Okay, and we can see this actually. No, let me rewrite for you. n0 to infinity c sub n x minus the center to the power of n. The first term, of course, is just c sub n, because this will be 0 and this is 1. And then c sub 1, x minus a to the power of 1, c sub 2. I have to catch my momento. A to the power of 3, and so on. And if x is A, if x is exactly the value of the center, we can see all of the terms are 0, 0, 0, 0. The only term that will stay is C sub n. And this is telling me that my summation, my infinitely like term, the summation of infinitely many terms is a finite number, which means, of course, the power series is convergent. Okay. That means we will, of course, practice, and I can show you an example. But what is important to know, again, when we will follow our steps, we will follow our procedure to find an interval of convergence, and you will probably have the case that you will end up, no numbers works. Like all of the numbers is giving me divergence. Please always remember and come back and say, hang on, we do have a one number that will always give me convergence, which is exactly the center. And we can read this right away from the given formula. Okay. Let's start. For what values of x, the series, the power series, the summation from 0 to infinity n factorial x to the power of n converges. I think it should be. Is convergent. Oh no, I do have is. Okay, it's just my English. Okay, that means the first question that I always like to ask, what is definitely, no. First of all, can you tell me what is the center? What will be the center of an interval, if I will even have the interval? It's 0. We can see because we're subtracting nothing, like x to the x minus 0 to the power of n, right? That's we can see a is 0. That's the center. Okay? That means if I will draw my potential interval, I don't know, definitely this is a center. Okay? And if I will end up not even having an interval, I can always say what values of x is giving me convergence? Definitely 0. I can even start this, definitely 0, even if it's 1 point. Yeah. Okay, but now what we will do, in order to find an interval, we will always use, maybe always is too strong, we will usually use the ratio test. We remember the ratio test, yeah, section 11.6, because what's happened, we have this formula, which is of course the coefficient C sub n, and this could be anything. Now is the factorial. We may have an exponential form, we can have a power form, we can have a rational function, like a rational expression, everything. And we will always have a power form, x to the power of n. And we know that the ratio test is really good if we have the mixture of few different expressions. That's the reason that the ratio test is perfect. Okay, I typed the solution on the other slide, but I will do it with you. Ratio test. And we remember, it's just the limit at infinity of a sub n plus 1 over a sub n, absolute value. And now the absolute value is extremely important because I do have x, okay? And x could be any number. That means we have to keep it, unless we know that it's all of the terms are positive. Okay. That means a sub n plus 1 will be n plus 1 factorial, x to the power of n plus 1, which is this. Yeah, because plus 1 means x to the power of n times x to the power of 1. And then n factorial, x to the power of n. Okay, I can cancel this. And we also know that we can easily simplify the factorial. N plus 1 factorial, it's simply n factorial times n plus 1. Let's keep this. Okay, another cancellation. And now, limit, of course, only is related to n, because we can see, we know that n goes to the infinity. So I will kind of separate. I will write n plus 1, and I don't need absolute value for this, but I still have x. And I will keep the absolute value for x. And always, to compute a limit, we will focus on the n expression, like the expression that contains n. Okay, n plus 1, infinity plus 1, infinity. That means big numbers times anything is just infinity. It's infinity. It's huge number. Yeah, I can even say this limit is infinity. And now, based on the ratio test, if the limit is infinity, simply the series that we testing is divergent. That means the power series is divergent. Because doesn't really matter what I substitute for x, I will always have infinity. Like 1, 2, 3, 4, 5, -1, -2 times huge number is huge number. That means it's theoretically divergent, but that's what I said. Do we have at least one number that will give me convergence? Of course, 0. Yes, Ryan. All of my questions are. I mean, all of the answers to my question are zeros. And yes, exactly. That means this is the moment that if you will get infinity, that's our conclusion, and it's fine. We still have to remember, hang on for a second, we do have one number that will give me convergence, and it's actually 0. Okay, that means I don't even have like an interval, just 1 point. How can I write this? I will write that my interval is simply a set of one number, 0. Okay? And now the question for my students, what do you think, what will be the radius in this case? What's the radius? Like, what is it's exactly, it is 0. Yes, Keith and Ryan, thank you. Because radius is theoretically the distance, right? The distance that I'm going away from the center. That's mean what I'm doing. From 0, I'm like not moving to the right, to the left, because it's just 0. Okay? And I can, of course, say that the center is 0, because that's the three things: an interval of convergence and the radius. Okay? That means radius is 0 because we're not moving. Okay, good example. Let's do another one. We do have 3 different cases. Okay, for this interval of convergence. That means this is one of them, specific, yeah, because we can see only 1 point. Let's see another one. Oh yeah, you can pause the video and you can check this solution. It's the same thing. Okay. Now, for what values of x does the series converge? And it's the summation from 1 to infinity, x minus 3 to the n over n. Okay. That's me now. Who can tell me what is the center? Right away. What will be the center? Yes, finally not 0. The center is 3. Please remember, not -3, right? It's 3. That means we know that definitely, again, whatever happens, of course, applying the ratio test, whatever happened, I definitely have at least 1 point for convergence, because all of the terms will be 0, and I'm fine. It's a finite number. Okay, and actually we will get 1, because starting from the second term, everything will be 0. Oh no, we're starting at 1, everything will be 0. Okay, never mind. We know that at center we do have convergence. Let's do the same. Ratio test. Limit at infinity. Now I will write the ratio, n plus 1. Okay, limit at infinity, x minus 3 to the power of n and x minus 3 to the power of 1, and then n plus 1, and dividing by reciprocal, absolute value. Okay, quite easy to simplify. And what I will do, actually, let me save some space. I will combine the n and n plus 1, and I still have x minus 3. Okay, and now, because the limit is only related to the n expression, everything else is a constant. And I don't have to keep absolute value, only for the x part. Okay, okay. Can you tell me what is this limit? It's, yeah, it is actually 1. That means 1 times x minus 3, it is absolute value of x minus 3. That's what I have. Okay, I can possibly write the answer here. Just to, okay. That means we do now, this is the case, that my answer based on the ratio test is in terms of x. Based on the property of the ratio test, it is known that the answer must be less than 1, then my tested series is convergent. That means you can see we actually have to deal with the nice inequality with the absolute value, because the solution of this inequality will give me convergence, because my answer must be less than 1. Right? That's mean again, important moment to know how to find an interval of convergence. I will copy this inequality, x absolute value of x minus 3 less than 1. In order to solve this, I will rewrite without the absolute value. It means we know that this quantity must be less than 1 or greater than -1, positive, negative. And then I will add 3 to both sides. This will be 4, and this will be 2. Okay, perfect. What I can do, I can even try, I'm trying to organize. I can put the numbers 2 and 4, and let's see if 3 is the center. And I believe it is the center. Yeah, I can say A. Perfect. Who can tell me what is the radius? The radius is 1. That means we do have a center, we do have a radius. Perfect. The distance from the center to the edge is 1. Okay. But now we still have one thing to do. Hang on. And are we, maybe I can keep here. We know what is that one. Okay, that means I can say that an interval of convergence is between 2 and 4, but the problem is the endpoints, right? Yes, yes, thank you, Ryan. I think you watched my previous video, the old video, which is really good. Or maybe you just read the textbook. I will put the question mark, because now the problem is with the endpoints. Okay? And why is the problem? Because the endpoints are not really tested by the ratio test. Let's see why. If I will take 2, and if I substitute x equals to 2, 2 minus 3, -1. Absolute value of -1, it's 1. And also we do remember, if we're getting 1 of that limit, the ratio test is inconclusive. The same 4. 4 minus 3, 1. 1, the ratio test inconclusive. That's what we will do. We will simply take the quantity 2, take the quantity 4, and substitute to my power series, which of course, it will be not power series anymore, because we will lose that variable. Okay, x equals to 2. Let's see what's happened. My formula is defined, let me do for the first time nice colors, because later we will speed up. 2. And what I'm getting, 2 minus 3, it's -1 to the n over n. Do you remember this beautiful infinite series? It's alternating harmonic, really good. And it's of course convergent. And the good news is now, if we end up doing this, testing the endpoints, we have to be quite quick to like assess this infinite series. I will not ask you what test you use. I will not ask you because I'm assuming that you mastered that skills, you know everything. The only message that I would like to get, the only output is if it is convergent or not. That means I got convergent, which actually you're good, yeah. It is convergent, which means 2 is a good number. I will include the endpoint 2. Okay, and let's do the same way for 4. Oh, different shade. from 1 to infinity, 4 minus 3 to the power of n over n. Okay, I have to put 4. And of course, 4 minus 3, it is 1. 1 to the power of n is just 1. This one is just harmonic, yes? Thank you, Ryan. And of course is divergent. Really good. Which means I will remove my question mark and this will stay open. That means this I can include 2, but I'm not including 4. And I can tell you that we may include both endpoints. We may not include actually none of them. That means really depends on the formula. Okay, but that's how we actually testing the endpoints. Perfect. That means this is like this is the common example to find an interval of convergence. We have interval, we have radius, we have center, everything. Okay, and let's see one more. That's my solution. You can pause the video, but I still think my handwriting is better than the typing. Okay, oh, probably you will think it's crazy, but let's see. Because this is like one of the, it's of course, we can see it's definitely the power series. I know the formulas are crazy, but it's one of the specific one. We have lots of application, and we call this like Basel function. It's of course based on, we have specific features of this function. But the question that I ask, I state, find the domain, which of course means exactly the same. Looking at the definition, which means is the power series, domain means an interval of convergence. We know that. Okay, that's what we have. -1 to the n, x squared to the power of n, 2 to the 2n, n factorial squared. Oh, hopefully by the ratio test I will simplify everything. But as always, I will start with this question. Who can tell me what's the center of this interval? What is the center? Of course, it's 0. Really good, because you can see x, we have x, of course, even square, doesn't matter, but it's just on its own. We're not subtracting anything. That means the center is 0. And at least x equals to 0 will give me the convergence. Definitely. Okay, let's see if I can do really quickly my ratio test. Okay, we will try to add 1. Yes, since it's absolute value, of course, I will remove that because absolute value will make everything positive. That means I'm not focusing on that part. X to the power of 2n plus 1. 2 to the power of 2n plus 1 and n plus 1 factorial, and actually it is squared. And times the reciprocal, 2 to the n factorial squared, and x to the power of 2n. We can simplify. Let's see. This will be x to the power of 2n, and if I will distribute to x to the power of 2. This is 2 to the power of 2n, and I can maybe write n factorial. Of course, it's squared. 2 to the power of 2n, 2 to the power of 2, because I'm distributing. And n plus 1 factorial, I can rewrite as a n factorial times n plus 1. And it's squared, then I will repeat. And what's left? Let's see. Let me take this. Oh, did I miss something? I missed something. I missed this part. X to the power of 2n, of course, because this must be gone. This is gone. Factorial, gone. Okay, that means what stays on the top? 1 and 4, n plus 1 times n plus 1, and just x squared on the top, right? Because you can see I'm kind of collecting all of the n's and I am leaving all of the x's at the end. I don't even need the absolute value because it's squared. Okay, who can tell me this limit? 1 over huge number. Yes, my favorite answer today, 0. And 0 times like any number in this case, it's simply 0. Okay, that means 0 means this is number always. Doesn't really matter what I substitute instead of x. 1, 2, 3, 4, 5 times 0 is always 0. I will always get 0, always number less than 1. My infinite, my power series is convergent everywhere for all x's, any numbers. This means like all real. Let me put for all real numbers. And let's see if this works. This is my center, 0, and the interval of convergence is simply from negative infinity to positive infinity. And now the question for you, what do you think, what will be the radius? It's probably funny answer because we're not really treating infinity like as a number, but actually, yes, we will say the distance to the edge is actually infinity. Okay, that means this will be, remember, okay, please remember, it's in this case, it's just, it's kind of common sense, but sometimes we may argue because it's not a number. Okay, really good. Let me, one thing just because about this radius, let's just pretend, like I don't have the formula, but let's pretend that the center is 2, okay? We will get the center from the formula, the center is 2, and we will do the whole work and we will get the same situation. An interval of convergence is from negative infinity to positive infinity, but the center is 2. What you will state as a radius? It's, oh yes, okay, that means it's the same thing because we know it's infinity, it's not equal to the infinity. It could be, that means this is still a huge number to this direction and a huge number. That means even if this 2 doesn't really look like a center of my interval, right? But actually it is. Yeah, that means just in case that we will not be confused. Okay, I will keep this. Yeah, the bottom part of this slide is not related to this question. It's just the additional question. Okay. That's what we did. Oh yeah, that's my typing. I will skip, for now, I will skip this. This is just like a few information about that function because it's interesting because this is power series, which of course is a function and is defined everywhere. But no, don't look at this. I will explain this maybe a little bit later on different, a little bit easier formulas. Okay, that's what we did 3 different examples of the interval of convergence, and we got, I don't know, I want different, okay, and we actually have these 3 different cases. We know that the power series is convergent at the center always, or we may have a case that is convergent for all of the values, or we may simply have like an interval where the endpoints are the finite numbers. Yeah, that's what we did. And let's see. We know that this is just, we know the terminology. Radius of convergence, interval of convergence. You're good with this. And too much typing, Kasia. Okay, this one. This is just like kind of like to have the like a visualization of what I was saying. That we can see the pink is an interval of convergence. That's the center, and of course, A plus the radius will give me one endpoint. A minus the radius will give me the other one. Radius is just the distance, and this is the values of x that is convergent Everything outside it will give me divergence. And please note at the endpoints, we may have the endpoints not included, included. I will not actually mess up. We can see the open or the bracket. And remember, always we have to test the endpoints. Okay. And this is just the summary what we did. We can see an interval was just the center and the radius is 0. An interval was all of the numbers, the radius is infinity. And this one is, of course, the radius is, of course, 1 because it's the distance from 3, from the center. Okay, I mean, you can just, it's just 3 different examples. Oh, and even the geometric one, because the geometric one, we didn't really use the ratio test. We knew right away based on the geometric property. Yeah, and even looking at the formula, we can see that the center is 0. I think I mentioned this. And actually, one more note for the geometric one. When we decide to use the geometric property and to get the interval of convergence, because we might, remember, we don't have to test the endpoints, because the endpoints will not work anyway. If we're not using the geometric property, just the ratio test, we have to test the endpoints. But not on this, because -1 and 1 will give me divergence anyway. Okay. And we will skip this. Okay, that means I have a few more examples, but we don't have to do it. I will skip this one. I think I did solve on my previous of the old video, but let me just find, that's the solution. That's also a nice example. I'm just looking. Oh, I don't have any multiple choice. Oh, I thought that I have some multiple choice question. Okay, that's what I will definitely do. I will grab a few multiple choice, even maybe from the weekly assignments, and I will solve it for you. Okay, like a few, I will ask, find the interval of convergence, find the radius of convergence, and of course the center. Okay, because I really thought that okay, I will not solve this one because yeah, okay, let's just leave it. But I will switch off my camera. Now, of course, I'm supposed to start the next session, but I don't want to keep the session long. Okay, what I can do, because we do have nice things in this session too. I mean, in this section. Okay, what I will do, I will finish the session, okay? This was the session just for the 11.8, and I hope was helpful, okay? Thank you for joining me, and thank you for answering my questions.